Go ahead and put your name, date, and period. Today we're covering section 1.3, midpoint and distance. Our objectives today: use the midpoint formula to find the midpoint of a segment drawn on a coordinate plane. Use the distance formula to find the length of a segment drawn on the coordinate plane. A midpoint of a segment is the point that divides the segment into two congruent segments. So it breaks it into half and half. That is a midpoint. The midpoint of PQ with P is a point, and it's at coordinate x1, y1. I know that's a lot of letters, but it's just a point. Like it's the point 1, 2, or 1, 1, or 0, 0. Those are coordinates. And the point Q is at x2, y2. So to find the midpoint, we're going to use this formula, M equals x1 plus x2 divided by 2. Now think about that. If we are trying to find halfway between a place, between point A and point B, we would take the whole distance and we would divide it by 2. That's what we're doing right now. And then we would have y1 plus, what do you think? y2 divided by 2. And that will give us a coordinate for the midpoint between 2 points. The distance formula is used to find the distance, or the length of a segment in the coordinate plane. The distance D between 2 points, let's say P and Q. So how do we find the distance between 2 points? And it comes from the Pythagorean theorem. So this is the distance formula. D equals, and in the Pythagorean theorem, you needed the square root. If you remember, a squared plus b squared equals c squared, you end up using the square root. So we're going to take the square root, make a big square root, of x2 minus x1, and we are going to square that. So put it in parentheses. We're going to square it. That's like the a squared piece, plus y2 minus y1 squared. That's the distance formula. And that is the distance between P and Q. How are we going to use these formulas that we just learned? Leave it up there in case some of you need it. Find the midpoint for each segment with the given endpoints. So to make this a little bit more visual for you, to show you where a midpoint actually is, we will graph these points. So go to -2, Oops, I didn't mean to write there. -2, comma 5. So let me erase that little dot. It was very sensitive. -2, comma 5 is right here. 8, comma -12. So I'm going to need to scroll so we have some space to get to -12. So we're going to go right 8 and we're going to go down 12. So that is going to be a segment. So I'm going to draw a line between those 2 points. And we want to find the middle of that line. Where is the midpoint? So we will use our equation or our formula that we just came up with, that you just learned, the midpoint. And we'll just rewrite it again. It's going to be x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. All right, so x is going to be the first number. So we will label this as x1, and we'll label the 8 as x2. So x1, we're going to substitute in with -2, and we'll substitute 8 in for x2. And then we'll divide that by 2. For our y's, y1 is our 5, and y2 is our -12. So y1 is 5 plus -12. We're going to divide that by 2. Then we're going to have a comma in between because this is going to end up being a coordinate, a point. You'll see that after we figure it out, we'll put it on the line. -2 plus 8 is 6. 6 divided by 2 is 3. And 5 plus -2, or I'm sorry, 5 plus -12 is -7. And -7 divided by 2 is -3.5. Where is that on our graph? So let's find that. -3.5. Wow, it's right in the middle. That is the midpoint. It's half of the line from either direction. Okay. For the next one, since it's decimals, we're not going to graph it. We are just going to use the midpoint formula. So I'll leave it so it shows a little bit so we don't have to write the midpoint formula again. The midpoint formula is right up here, and it's in another place in your notes as well, in the beginning in the definition section. So we will start with labeling these x1 and x2. The second point is y1 and y2. And then we'll plug those into the midpoint formula. So the midpoint is going to equal coordinate. We have for the x's 2.5 minus or plus -6.2. And we're going to divide that by 2. And then we have for the y's -7 plus negative 3.8. And you can use a calculator, just make the negatives positive. And then remember, if I'm owing money and I'm owing money again, it's gonna still be owing money. So you just add them together and that'll be your total negative. Figure these out with your calculator. So 2.5 plus negative 6.2 is negative 3.7 divided by 2. And 7 or negative 7 plus negative 3.8 is negative 10.8. If you get a scientific calculator, I can teach you how to use it to do positives and negatives. So that is our coordinate, but we could simplify it more to make it like if we had to actually graph these points, we could divide them by 2. So that would equal negative 1.85, comma, 5, negative 5.4. And that is the midpoint between the points E and F. We're going to use some algebra to derive the distance formula. So let's say that we have random numbers. And to represent those, we use X and Y. So we have X1, Y1 on this diagram, and that's a point. And we have X2, Y2, that's another point. How could we find this diagonal distance? Well, if we make a triangle here, and we knew the sides of the triangle, then we could figure out the diagonal. So this point down here on the triangle is X2. And the point on over here on the triangle, that's at X1. So we could find the horizontal distance of X by doing X2 minus X1. That would give us that distance for the horizontal. Now for the vertical, this point down here is at Y1, and the point up here is at Y2. So we could find the vertical distance by doing Y2 minus Y1. So that is like the Pythagorean theorem where we have two lengths of a triangle. We have side A and we have side B. So this would be the Pythagorean theorem side A, and this would be side B. And so if we wanted to find side C, we would have to square these sides, A and B, square side A, square side B, just like in the Pythagorean theorem, A squared plus B squared. So we're going to put a plus between. And then we would take the square root of this to find C squared. So we are going to take the square root of everything. And that will be the distance from these 2 points, X1, Y1, X2, Y2. So this will be the distance. And that is derived from the Pythagorean theorem. So we are going to use this formula on this example. A pitcher throws a ball to a batter who hits the ball to the shortstop. If the ball travels in a straight line between each, what is the total distance traveled by the ball? Round your answer to the nearest tenth of a foot. So how far does the shortstop need to throw the ball to reach the first baseman? Let's look at this picture. Where is the shortstop and where is the first baseman? Okay, so the shortstop is right here. And the first baseman is right here. And we want to know how far does he have to throw? You don't have to draw this line, but I'm going to draw it just so you can see the math. If you'd like to draw it, you can. How far is that? Well, let's start with the coordinates. So the shortstop is at 5, 10. And the first baseman is at 10, 0. Okay, I'll abbreviate. Shortstop and first baseman. Okay, so we had 5, 10, 10, 0. Let's label those with X's and Y's. So this is going to be X1. This is going to be X2. This will be Y1. And this will be Y2. Now we're going to use the distance formula. So what we just derived from the Pythagorean theorem, we are going to subtract our X's. So we're going to do 10 minus 5. And we are going to subtract our Y's. 0 minus 10. The order matters. So when I did this, I did the X2 minus the X1. And I did the Y2 minus the Y1. So if we start with the Y2 and the X2, then it has to be the same for each part of this equation. Now we are going to square, just like in Pythagorean theorem, a squared plus b squared. And then we're going to take the square root of that to find the distance. Right. 10 minus 5 is 5. 0 minus 10 is negative 10. We are going to square each piece. We're going to add them, and we're going to take the square root. So at this point, I'm just simplifying this down. And each step will get more simplified. 5 squared is 25. And negative 10 squared. Well, negative 10 times negative 10 is positive 100. We're going to add those and take the square root. So we're just simplifying in each step, just getting more simplified. 25 plus 100 is 125. And the square root of 125 is 25, right? Or no, it's not. The square root of 625 is 25. But they asked us to round, back up here, remember they asked us to round to the nearest tenth of a foot. So I'm going to put this in my calculator. The square root of 125 is 11, approximately. This is irrational. It's approximately 11, and then I have 0.18, but I can only have one decimal because a tenth is one decimal place. So it's going to be, instead of 0.1, it's going to be 0.2 because the 8, after it's 11.18, the 8 makes us round up. So he needs to throw it 11.2 feet. And here's a little summary. The distance formula resembles the Pythagorean theorem. The square of the length of the hypotenuse, that's the diagonal side, right? Hypotenuse of a right triangle is the sum of the square of the other sides. The other sides are A and B, right? A squared plus B squared equals C squared. So the distance formula is very similar to the Pythagorean theorem. They come, the distance formula is derived from the Pythagorean theorem.